This is the depth buffer, and in this case I am using it to project particles onto the solid objects. In this shader, I use the depth buffer to get a foam effect and also to get a dip effect by changing the color of the water depending on the distance. The depth buffer is obtained in the rendering process called dip testing. For example, in this case I get the distance of the individual fragments of this object and compare them with the depth buffer. Since this is in white, I render the object in the depth buffer. Also, I will render its color in the color buffer. With the next object, I will do the same, but since there is already something in the depth buffer, I will take the distance of the fragments of the next object and compare them with the depth buffer. Since the object and its fragments have a smaller distance, I will override the depth buffer, and I will also override the colors in the color buffer. As with the last object, I will do the same procedure, but in this case the object has a greater distance than the depth buffer, so I cannot override the color pixels. I can only draw the color in the areas that are empty in the depth buffer. This process is relatively easy to understand and doesn't require arranging the objects, since solid objects override both the depth buffer and the color buffer. However, there is a big difference between solid objects and transparent objects, since transparent objects do not draw in the depth buffer, as you can see in the following example. If I switch this object to transparent mode, it will no longer be rendered in the depth buffer. In this example, I have created a shader that can change its state from solid to transparent using macros. As you can see, I have disabled the uniform variable and also the alpha output variable. Now, I will disable writing to the depth buffer of the capsule object, so it will be drawn just before any solid object. If I also disable the depth buffer on the cube, the objects resume their previous order, but now I can change their order in the render priority. This option does not work for solid objects that write to the depth buffer. I will remove the command to disable the depth buffer because now I will make both objects transparent and they do not write to the depth buffer by default. I'm going to change their opacity to indicate that they are transparent objects. Now the objects that do not write to the depth buffer need to be arranged first. They can be arranged by default, or we can specify the order in which they are rendered. Alpha blending is the rendering of transparent objects. It mixes the colors of the color buffer with the object that is currently being rendered. But as you can see, it has this serious order problem, since this object consists of 3 different geometries that overlap. If we look at the shader, it is a transparent object. One way to solve this problem is to use the prepass alpha, which is a kind of depth buffer specifically for transparent objects. In this case, it doesn't solve the problem very well because the object is rendered incorrectly at the beginning of the blend and then rendered correctly when the value is close to 1. And it does produce the horrible jump from the previous tutorial. We have other options like alpha hash, which allow you to use a noise value to dissolve the object. We can vary the size of the noise with the alpha hash scale parameter. Next, we have alpha sizer. Here, I will use a distance field in the XY plane of the object. Here, you can see the distance field. Now, I will make a cut with alpha sizer. This works very well for particle textures, for example. And finally, we have discard. With the same distance field, I can discard the fragments that are less than a certain value, for example 2 meters,